Hi, welcome to Study with Rishi. This is 10-minute system design. In this video, we will talk about data partitioning. Data partitioning is a technique to break a big database into many smaller parts. In this process, we split up a database or a table across multiple machines. But why should we split up a database? Well, after a certain scale point, it is cheaper and more feasible to scale horizontally by adding more machines to the system than to grow it vertically by adding beefier services. By data partitioning, databases can be managed better, they give better performance, availability can be increased, and also better load balancing. These are the four advantages of using data partitioning or doing data partitioning. Now, let's talk about four most popular ways in which we can partition database. The very first is horizontal partitioning, or we call it range-based partitioning. In this scheme, we put different rows into different tables. For example, if we store different locations in a table, we can decide that location with zip code which is less than 10,000 are stored into one table, and those locations with zip code greater than 10,000 are stored into a separate table. This is called range-based partitioning, as we are storing different ranges of data in different tables. Horizontal partitioning is also known as data sharding. The key problem with this approach is that if the value whose range is used for partitioning isn't chosen carefully, then it will lead to unbalanced servers. Some of the shards will have more data than the others, which defeats the purpose of sharding, or we call it non-uniform distribution of data. Now let's talk about key or hash-based partitioning. In this type of partitioning, we apply a hash function to some key attribute of the object we are storing. That gives the partitioning number. For example, if we have 4 DB servers and our ID is a numeric value, in this example, the hash function could be like ID mode 4, which gives us server number where we can store or read that record. This approach would ensure that a uniform distribution of data happens among multiple servers. The fundamental problem with this approach is that now we have a fixed number of DB servers. To add new server means changing the hash function, which would require redistribution of data and downtime for the service. A workaround for this problem is to use consistent hashing, which we will talk about in a dedicated tutorial. The third type of partitioning is vertical partitioning or feature-based partitioning. In this scheme, we divide our data to store tables related to a specific feature in their own server. For example, if we are building an Instagram-like application, we can decide to place user profile information in one DB server, friend list in one DB server, and then photos into another DB server. Vertical partitioning is straightforward to implement, and it has a low impact on the application. The main problem with vertical partitioning is that if our application experiences additional growth, it scales, then it may be necessary to further partitioning of feature-specific data across multiple servers, feature-specific databases across multiple servers. For example, if there are too many photos in one photo server, it will be very large to handle gracefully. The fourth partitioning scheme is directory-based partitioning or map-based partitioning. We can create a lookup service that knows our current partitioning scheme. So to find out where a particular data entity resides, we query the lookup server that holds the mapping between each key to its DB server. This way we can perform tasks like adding server to the DB pool or changing our partition scheme without having an impact on the application itself. But in order to do that, we would require to update lookup service. And the lookup service becomes a single point of failure and the bottleneck of our complete application system. Now, let's talk about some common problems of data partitioning. The very first problem we can talk about is join and denormalization. Performing joins on a database that is running on one server is very straightforward. But once a database is partitioned and spread across multiple machines, it is often not that feasible to perform joins that span data partition. Such joins will not be performance efficient since data has to be compiled from multiple servers. A common workaround for this problem is to denormalize the database, so that queries that previously require joins can be performed from a single table. But due to this, there would be data inconsistency issues. Yeah. The second problem is referential integrity. Trying to enforce data integrity constraints such as foreign keys in a partition database can be extremely difficult. Most RDBMS do not support foreign key constraints across databases on different DB servers. This means applications that require referential integrity on partition database often have to enforce it in application code, which adds another layer of complexity to the overall application. Third problem which we usually face is rebalancing. There would be number of reasons we have to change our partition scheme, like the data distribution is not uniform, or there are a lot of load on one partition, one shard. This will include downtime of services, and we will be required to move data around. So yeah, there are problems. So these are the common issues we face with data partitioning. This was the video about data partitioning. If you like the video, please consider liking it and subscribing to the channel. I'm also a mentor at Scalar Academy, and if you have a question around it, I have given my details in the description of the video. Do consider sending me a ping. In the end, I thank you for your time. I hope you liked the video. Thanks for watching the whole video.